Can everyone see the presentation?
Yes.
Yeah? Okay, good.
Yes.
Yes.
Thank you. It's Irelina here.
Thank you. Okay, let's begin. So today we'll be talking about the second section in the white paper, How Humans Change Climate. This is the second webinar series. And so I'll go into some details about how, where I got the numbers from and, how I did the calculations. But I'll go into a little depth so that you understand where it came from originally. So this is about section 2. This is the second in the series. The first one, we already have a video up on the website. So if you haven't watched that, please go back and watch it. Now, I also want to point out that there is a change in the next month. I'm going to do the webinar next month on February 1st instead of February 8th as originally scheduled. Can everyone hear the audio? No?
Yes, I can hear you.
Okay.
Yes.
Yeah. Okay, I think a couple of people are having problems with the audio. Anyway, so because of schedule conflicts, I moved it ahead to February 1st because February 8th, I'm going to be on a plane going somewhere. So yeah, so again, this one, I'm going to talk about it in 4 sections again as background and context. And then we'll talk about the IPCC's framing, the way framing is done in the IPCC. And then we'll talk about a different way of framing it, which is what I've been doing in the white paper, a source-based framing. And then we'll go through the scientific data. Now, I need to go through the background again because I think a lot of things have happened since I did the overview that makes me want to revisit some of this. So the context is, again, the UN Framework Convention on Climate Change was formed in the 1990s. And it is a political organization because it's basically a whole bunch of countries coming together. And their purpose is to stabilize greenhouse gas concentrations in the atmosphere at a level that will prevent dangerous human interference in the climate system. At least that's their agenda. Now, so the IPCC, the Intergovernmental Panel on Climate Change, reports to the UN Framework Convention on Climate Change. So it is the body, the UN body, for assessing the science related to climate change. Now, the purpose is still the same, to stabilize greenhouse gas concentrations in the atmosphere, etc. But it is a scientific body answering to a political organization, and it is being managed by a political organization. So we have to look at it in that context. The scientists are all trying to do the right thing, but there is a political body around them. So this reminds me of what happened to me in the fire. I've talked about this before, but basically this was a fire in our home in New Jersey in which a car caught fire. So this was a brand new car that I had bought the previous day, and the next morning it caught fire. And you can see it was blazing away in this middle of the garage. So when we identified that the car was the cause of the fire, I called up the dealer and I said, "What the hell did you sell me?" And he asked me to contact this engineer at the car company. And the engineer basically explained to me how it happened. He said, they routed a fuel line very close to the windshield washer heater. And if the fuel line starts leaking and the car is stationary, then the fuel accumulates around the heater and eventually it ignites. And he said, mine was the 8th car that caught fire, and headquarters is waiting for 10 cars to catch fire before they issue a recall. And they'd already fixed the problem starting May of 1993. My car was manufactured in March of 1993. So therefore, my car had the problem. So anyway, that's the background. And then came a scientist to examine the fire. And the scientist was hired by the car company. So obviously the scientist had to find an explanation for the fire that did not involve the car. That was his job. And that's what he was trying to do. And so I tell this story because it reminds me of exactly what is going on with the IPCC. So they have a predicament because they have a political body that's telling them what they cannot say. What they can say, but what they cannot say. So you cannot indict certain things. And the number one thing they cannot indict is given by the statement that President George H.W. Bush made, which is that the American way of life is non-negotiable. So when you say the American way of life is non-negotiable, then you are told as a scientist you can never do anything, say anything that would indict consumption, a consumer society. So in fact, at the Paris meeting in 2015, one of the negotiators came and told me that. She told me, we have been told never to mention the C word, consumption. Now, why is this a problem? Well, if the American way of life is non-negotiable, the Global Footprint Network has calculated that the carrying capacity of the planet is 1 billion humans with the American way of life. So there is this idea that you can only support 1 billion people living this kind of lifestyle. And so the scientists are being forced to adhere to this. And so now, we have run out the clock so much that now the scientists are saying the time is running out so fast that we have no choice. Either we make this work within the existing economic paradigm or we fail. So we are trying to solve climate change within the existing economic paradigm. And I think this is a route to failure. This is not or we fail, it's just we make this work within the existing economic paradigm, we will fail. Because I'd say that there are 3 options for a vegan world. We are here in the middle, where we are saying we need to get to a vegan world after the human population is down to 1 billion. Okay, that's the situation that we are in right now. Now we have a choice. We stay there. If we stay there, we are going to go to be vegan on Mars. So if you stick with the existing economic paradigm as a predator species, we will have no choice that to face extinction, and therefore eventually 1 or 2 people are going to go to Mars and be vegan over there. Or we have to transform to a new economic paradigm and become the caretaker species of this planet. And when we transform to a new economic paradigm, the old carrying capacity numbers no longer apply because it's not that kind of lifestyle that we are living. Okay, so this is the context. Now, within this context, I want to talk about how IPCC is framing climate change. And they're framing climate change as a gas-based problem. Okay, so what I mean by that is, exhaust gases are causing climate change. Okay, so exhaust gases from all human activities put together are causing climate change. So then we say, well, what are these exhaust gases? How much climate change do they cause? What is the number 1 exhaust gas, etc.? So that's the kind of question we start asking when we do that. So the IPCC has estimated that CO2 is the major exhaust gas that's causing climate change because it's causing 1.66 watts per square meter of heating on the planet. So 1.66 watts per square meter of heating. So for every square meter, it's as if you have put a 1.66 watt bulb, a heater. Methane, nitrous oxide, fluorocarbons, and other greenhouse gases together are causing 1.65 watts. But if you look at what is the number 1, what is the biggest one? It's CO2, right? Methane is only 0.97, CO2 is 1.66. And then aerosols are causing minus 1.45 watts total of cooling. So eventually it works out to 1.6 watts. And this is what they were doing. They showed in IPCC AR4, the 4th assessment report that came out, I think, in 2010. So this is, and you can see that the numbers also don't add up. And I assume that there was some dependence between the numbers, and that's why they didn't add up. But anyway, they didn't add up in the number. And the equivalent of this, if we look at 1.6 watts per square meter, it's as if there is a CO2 in the atmosphere of 377 parts per million. Now, I had given numbers like this in the previous webinar, but in the previous webinar, I was using a CO2 doubling sensitivity of 3 watts per square meter. And IPCC AR5 is using a CO2 doubling sensitivity of 3.7 watts per square meter. What that means is that if you double the concentration of CO2 in the atmosphere, that's like adding a 3.7 watt per square meter heater on every square meter of the Earth's surface. Okay, so that's what they're using. I was using Hansen's number, so that's why the numbers are a little different. So anyway, this is like adding a it's as if this atmosphere has 377 parts per million of CO2. Okay. And if you look at it, you'll see that CO2's impact is almost the same as the total impact. So there was a focus just on CO2 because that's the number one gas. So we need to address that. We need to reduce that. Okay. So we then attempted to reduce that. And then within that, we looked at human CO2 emissions. And you look at human CO2 emissions over time. That's what is shown in this graph. Here is the time from 1850 to 2010. And here is the million tons of CO2 per year. And here are the different components in different color codes. So the way it is done here is land use is this much. On top of that, there is coal. On top of that, there is oil. And then on top of that is gas and cement and so on. So that's how it adds up, right? And if you look at how it is adding up, you will see that coal is the number one, is the biggest contributor. It's bigger than oil, is bigger than gas, bigger than cement, bigger than land use. Coal is the number one. So there was a big focus on, okay, let's get rid of coal because that's the biggest component of CO2. So there was this campaign to address coal, okay? So you can see how we were making these decisions and doing these campaigns based on how the gas framing was done in IPCC. So there was a big campaign against coal starting in AR4, and we shut down, actually Sierra Club has a count on how many coal-fired power plants have been shut down and how many are remaining, and 228 to go, 302 to be proposed or retired. And retired meaning they got changed to natural gas. The natural gas is also bad, okay? But when we do this, we are thinking that coal is the worst, therefore we need to get rid of the coal. So we campaigned against coal, and what happened? There was this Faustian bargain. This is what Hansen calls the Faustian bargain. The first thing he says in the Faustian bargain article is that we shouldn't be building any more coal-fired power plants. I absolutely agree with him on that. We're already in a deep hole. It's time to stop building more new ones, okay? But the existing ones, when you shut them down, you're going to cause aerosols to disappear. And aerosols have a cooling effect, and they stay in the atmosphere for just 5 days. So they're followed after 5 days. So every 5 days, we're just increasing the amount of aerosols. We're just adding more aerosols into the atmosphere every 5 days through burning coal and oil. Okay, so that's what he calls the Faustian bargain, because it says if you burn coal, you're going to cool the atmosphere, but simultaneously you're going to keep adding more and more CO2 that builds up. So which means when we finally have a day of reckoning, we'll have to clean up all that CO2 that we added. Okay? So that's what he means by the Faustian bargain. And you see that in the IPCC AR5, you will see that the CO2 did not increase by much. It went to 1.68 watts. Other heating from 1.65, it went to 1.68. This one went from 1.66 to 1.7, so just 0.04. But this one decreased, okay, from 1.45 to 1.1. And so the overall, it increased to 2.29 watts per square meter. So overall heating increased. And what that means is that the CO2 equivalent is now 430 parts per million. That's a 53 part per million increase in roughly 5 years that happened. So you can imagine that climate change is now accelerating because of what we did, right? And that's because we did a gas-based framing, and then we went about trying to address the main gas without thinking about consequences, the other consequences. If we keep doing this, and if we get rid of all of the aerosols, we will be heating it up to 3.29 watts per square meter, which is the equivalent of 518 ppm. That's like adding another 88 parts per million of CO2 into the atmosphere. Okay, we definitely get cooked if we did that. So that's the problem with the gas-based framing. So we need to instead look at a source-based framing. What I mean by source-based framing is look at what are the two main sources of greenhouse gas emissions. And the two main sources are animal agriculture, I call the killing machine. We're killing animals left and right, killing more animals in 4 to 12 hours than all the humans that ever died in wars throughout human history put together. And the second is the burning machine. So we have to look at each machine and say, what are these machines contributing? Animal agriculture, how much is it contributing overall? And how much are fossil fuels in industry contributing overall? And there is the overlap because some of the burning machine is being used to drive the killing machine. And some of that killing machine may be used to drive the burning machine. So there is some overlap in this. But it's a better way to analyze things. And it helps us understand what kind of action we should be taking today. So that is the context. And now let's look at the scientific data. And what I tried to do in section 2 of the white paper. So we have to start with atmospheric greenhouse gases over time. And here is a graph of the atmospheric greenhouse gases from year 0, estimated from year 0 up to the year 2010, I think. 2000, it's gone up. So here's carbon dioxide is in red, and carbon dioxide is in parts per million on the left. So it starts out around 280 parts per million. It's been there for a long time. And then starting in 1750, it started shooting up. Okay. So that's the red curve. And this is the axis for carbon dioxide in ppm. It's also the axis for nitrous oxide in parts per billion. Nitrous oxide is in black, and you can see it is out here around 265 parts per billion. And now it is here. Okay, it's around 315 parts per billion. Again, it's going up. Then methane is the purple curve, and it is shown here on the right-hand side. Its axis is shown here on the right-hand side, and it's in parts per billion. So from 600 is the bottom, and then it goes up to 2000 up there. So methane is the purple curve, and you can see it was very low here. It was around 750 parts per billion in 1850, and then it's now up here. It's at 1850 parts per billion. Okay. So it's at 1850 parts per billion, and methane happens to be something that decays very quickly. Carbon dioxide stays for a long time in the atmosphere. So there are radiative forcing calculations now based on the concentration of carbon dioxide in the atmosphere, concentration of methane in the atmosphere, concentration of nitrous oxide in the atmosphere. So this is how the IPCC has calculated things. So the radiative forcing for carbon dioxide is equal to the constant alpha times the logarithm of the concentration of carbon dioxide in the atmosphere divided by the concentration of the carbon dioxide that existed in 1750. Okay, so this is 280 parts per million, C0, and C is whatever it is today. So you can plug that in and you will get the radiative forcing, carbon dioxide. Okay. Now for methane, it's again a constant alpha times the square root of the concentration in parts per billion of methane minus the square root of the part concentration that existed in 1750. So this will be this is the main function, and then there is a correction that they add, and this correction is a function of the methane concentration and the nitrous oxide concentration. And it's kind of squirrely function, this really complex function. By the way, there's a typo here. Again, this is supposed to be an exponent, not times. So it's 2.01 times 10 to the minus 5 times mn to the power 0.75 plus 5.31 times 10 to the minus 15 and m times mn to the power 1.52. And it turns out that this correction is relatively small compared to this guy. And the same way, the nitrous oxide radiative forcing is also calculated by with similar function, square root function, and then a correction factor. Okay, so this is the original, this is straight from the IPCC. This is exactly how they do it. Now, in my white paper, I tried to do some simple calculations, proportional calculations based on this. But here I'm going to show you the actual calculations, so you can then compare it with what is what's going on. Okay. Now, methane decays exponentially. It's a simple decay function. So so any concentration of methane that's up in the atmosphere will become carbon dioxide over a certain time constant. So the concentration of methane, if you didn't put any more methane into the atmosphere, it'll keep coming down as an exponential function. So it's exponential of minus of t over tau I, where tau I is the perturbation lifetime. Okay, so then if you integrate that, you will get the 1 minus exponential, okay, tau I. So for methane, the perturbation lifetime in the IPCC is 12.4 years. So tau I is 12.4 years. So which means that the half-life is 12.4 times logarithm of 2, which is 8.6 years. So this is actual calculation. This is how you should be actually calculating it. Okay. So this is how the methane concentration decreases. And if you notice that in the atmosphere, the methane concentration has stayed constant for the last 10, 15 years, it's because we've been pumping methane into the atmosphere to replace the methane that has been decaying. So now based on that, now you can calculate, okay, for fossil fuel burning, the burning machine, what is the annual emissions contribution of the burning machine? So it's contributing 87% of the CO2, okay? And according to the AR5, there is 39 gigatons of CO2 emitted each year. Now, each ppm of CO2 is 7.8 gigatons. So which means this is equivalent to 5 parts per million of CO2. So if you count all of the CO2 that we've added to the atmosphere from fossil fuel burning and from land use change, it would have added 5 parts per million. But in reality, it only added 2.25 parts per million. Now I'm going to just calculate, assuming that all of it be added, okay, 5 parts per million. So then it is logarithm of 395 over 390 times 5.35, and then times 0.87, which is this. So this is the actual number, will be 0.059 watts per square meter if you calculate this out. Now for methane, I'm going to assume that it is only the square root part, that it is proportional to only the square root part, okay? So if we did that, then it's a square root of 1.85. This is 1.85 parts per million today, times minus square root of 1.72 divided by square root of 1.85 minus square root of 0.75. So this 1.72 comes from the 363 million tons of CH4. That is equivalent to 0.13 ppm, because 1 ppm of methane is 2.84 gigatons of methane. Now these calculations are all based on molecular weight, right? So the molecular weight of methane is less than the molecular weight of CO2. Methane is 4 hydrogens and 1 carbon. So that has 16, right? Carbon is 12, hydrogen is 1, so that's 16. And CO2 is 1 carbon plus 2 oxygens. So the molecular weight of CO2 is 44. Proportionately, it's 44 for every molecule of CO2 versus 16 for every molecule of methane. So that's how these numbers scale down. Okay. Now, 2.84 gigatons of methane is 1 ppm. Therefore, 363 million tons of methane is 0.13 ppm. So if you take it as the ratio of the square roots, you will get this times the 0.97 is the current radiative forcing of methane times 23%, which is 0.022 watts per square meter. So this 23% comes from natural gas. It's an estimate of how much natural gas leakage is causing methane in the atmosphere. So these two are the annual emissions of fossil fuel, the burning machine, from CO2 and from methane. And then comes the sulfur dioxide and the aerosols. So they are actually contributing in negative 0.95 watts per square meter of cooling. So overall, the burning machine is actually cooling us. Okay, that's what is happening today. Yeah? Because this 0.95 watts, negative 0.95 watts, is much, much greater than these two, the sum of these two. Now let's look at the annual emissions of animal agriculture, the killing machine. So it's about 30% of the CO2. Okay, 30% of this comes from animal agriculture. Again, I don't have the exact numbers for 2000 for AR5. I'm just taking numbers that taking ranges that people have calculated, and I'm taking the smallest range, smallest of the ranges. And the reason we don't have the numbers is because the IPCC or the FAO has not updated the numbers since 2013. So let's say it's 30% of CO2. So that works out to 0.02 watts per square meter. Same calculations. Again, assuming that all of the 39 gigatons goes up into the atmosphere and stays there, 395 or 390, times 5.3, 5.3. Then it's 37% of the methane, which with the same calculations works out to 0.035 watts per square meter. Okay. It's also on 37% of the land, and the opportunity cost of that land is 34.5 gigatons of CO2, so which corresponds to 0.06 watts per square meter. So all of this is heating up. So it's adding, right? All of this is adding. If you didn't have this killing machine, if you shut it down, you won't be emitting this 0.02 watts per square meter. You won't be emitting this 0.035 watts per square meter. And you'll start sucking down 0.06 watts per square meter. Okay, so you'll reduce that by that much. So this is the total contribution of the burning, of the killing machine, which clearly dominates over the burning machine. And again, there was a question about, so one of the questions I raised in section 2 is that why are we counting all of the CO2? Because we know by observation that when we put out 39 gigatons of CO2, only 17.6 goes into the atmosphere. Okay, and the way it is managed, the way it is shown in the IPCC's block diagram, is that here is the fossil fuel burning, 7.8 gigatons of CO2. Here is net land, 7.8 gigatons of carbon, okay? And net land use change is 1.1 gigatons of carbon. So from carbon, you have to translate to CO2 by adding 2 oxygen molecules, okay? So that's how it translates. This is 8.9 gigatons of carbon. So this is the extra that we are doing. And then they're showing all these other numbers. That is really part of the life cycle, annual cycle of life. The annual cycle of life is actually putting out about 200 gigatons of carbon into the atmosphere and taking down 200 gigatons of carbon, approximately. It's huge compared to the fossil fuel burning and land use changes. So you have a huge cycle which is pouring 200 gigatons into the atmosphere, taking around 200 gigatons. And the IPCC is making an assumption that that cycle is completely balanced.
May I interject for a second and ask Sarah to mute her microphone?
Okay. So there's 200 gigatons of carbon going into the atmosphere and coming down. And what the IPCC is also showing in this block diagram is that there is a mismatch. There is 2.6 extra coming down into land, and there is 2.3 extra coming down into the ocean. And so therefore, there is only 4 gigatons being added to the atmosphere, even though 8.9 is being pumped up. So then the question comes, is this 4.9 gigatons that we are adding, is that part of whatever we did in the previous years? Is that just coming down slowly? Or is it an instantaneous change in the photosynthetic cycle, this life cycle? See, our killing machine is operating on this life, okay? And they are not even looking at it in the IPCC. It's just not even part of the modeling. There is this huge amount of carbon being put into the atmosphere and brought down, and we are pretending that that's completely in balance, even though we are killing, I don't know, 70 odd billion land animals and trillions of sea animals. We're doing all this killing on that life cycle, on the carbon cycle of life, and we're pretending it has no impact. Okay. So the question is this 4.9 gigatons, is that an instantaneous change in what is happening on the carbon cycle, or is it caused by previous emissions of human beings?
Silas, I'm not hearing anything.
Oh. Can you hear it?
Yeah, it's a little low though. Can you start it over again?
Okay.
That simple statement is the key to science. It doesn't make a difference how beautiful your guess is. It doesn't make a difference how smart you are, who made the guess, or what his name is. If it disagrees with experiment.
Can't really hear it.
Sorry, I'm going to explain to you in words what he just said. Okay, it's a famous video. It's actually, you can watch it on YouTube. Basically, the way you determine things in science, you make a hypothesis. The hypothesis you say is the airborne fraction, which is 4 gigatons out of 8.9, which is 45%. You say the hypothesis is caused by accumulated decay of prior anthropogenic CO2 emissions from previous years. And then you have to do an experimental test to check if the airborne fraction increases as the rate of CO2 emissions increases. If it increases, that means that it is possibly caused by previous ones. Because if it is caused by previous ones, that's not going to change if you increase the CO2 emissions, right? It's going to still produce the same amount from the past. So therefore, the airborne fraction should increase. Now, if your observation is that the airborne fraction actually decreases as the rate of the CO2 emissions increases, then the hypothesis is wrong. Okay, it's very simple. If we see that it is actually decreasing as the airborne fraction decreasing as the CO2 emissions increases, then it is wrong. The hypothesis is wrong. And that's exactly what we see in reality. So here is the airborne fraction in blue, 7-year mean. And starting in the year 2000, we, as a species, started cranking up our CO2 emissions. So we increased it. It went from 1.5 ppm increase per year to 3 ppm increase per year average. Okay. So we just cranked it up, but the airborne fraction started decreasing. And Hansen actually wrote about this. So in his paper, he wrote, remarkably, the airborne fraction has decreased since 2000, a major role of nitrogen deposition in causing a large increase in net primary productivity. So what he's guessing is that it's caused because as we increase the fossil fuel burning, especially coal in Asian countries, we pumped up a whole bunch more nitrogen into the atmosphere, which actually increased the photosynthetic capacity of plants. And so the plants started sequestering more. So the airborne fraction seems to be an instantaneous fraction. So which means that extra 55% didn't even go up there. But all our climate models are based on assuming that all of this airborne fraction is coming from the past. And this is why they have so much variation in the models. So there are models like, these are two models that I took from the IPCC AR5. This shows the black is what the model is showing as the response of CO2 pulse in the atmosphere. If you put 1 gigaton of CO2 pulse in the atmosphere, that's how it decays over time. And here is another model. It's much smoother. Now, I used to manage an engineering team. And if I had two different engineers coming up with two different models like this, I would put them in a room and say, you figure it out. You tell me what is actually going on. Go run some experiments and figure out which is correct. But that's not what the IPCC is doing. So they have 16 different models and they're just averaging them all up. Okay? This is not how science should be done. This is how politics is done. So the scientific results that we're getting is really the results of a political decision. So climate models are many, but reality is one. There's only one reality that we are trying to predict with our models. So this is why George Box said, all models are wrong, but some are useful. Some are useful if you can predict enough about the reality that you can make some decisions based on that. And to me, climate models without nitrogen cycles, they cannot capture the airborne fraction correctly. And this is why you don't see anything in the IPCC that would capture this correctly. Also, the way the IPCC is modeling the way CO2 decays has problems in it. Basically, they are assuming that the CO2 decays as a sum of exponentials. Specifically, they have three exponentials. Okay, there's one exponential for the ocean acidification, one exponential for vegetation, and one exponential for deep sea sediments. So this is the fast process, this is a slightly slower process, and then this is the really slow process. And so they're saying, you know, when you pump up 1 gigaton of CO2, eventually only 0.217 gigatons stays there in the atmosphere after hundreds of years. About 0.259 gigatons goes into deep sea sediments, 0.338 gigatons goes into vegetation, and 0.186 gigatons goes into ocean acidification. That's an AR4 in the fourth assessment report. In the fifth assessment report, all these numbers changed dramatically. It became 4.304, 36.54. You can see it's almost doubled, 394.4. And the coefficients also changed because they are just doing curve fitting on an average of all the models. And suddenly by AR5, there were lots of models. There were like 15 different models. And in fact, a lot of the models seem to be copies of each other, okay? If you ask me, because I think they took the same code and just tweaked a few things here and there. And unfortunately, in all of the climate models from which these coefficients are derived, the airborne fraction has not been modeled correctly. Okay. Furthermore, the sum of exponentials is not the right way to model this. Because how does the ocean know that it needs to stop at 0.276? It shouldn't take all the extra other CO2 that's still there. It doesn't know to stop. This is not how physics works. So the way physics would work is imagine that you have cylinders, right? So let's say cylinders with a surface area for atmosphere corresponding to those coefficients. So here is the atmospheric cylinder, there's an ocean cylinder, there's a vegetation cylinder, and the deep sea cylinder. And imagine there is a thick pipe between the atmosphere and the ocean. There is a much thinner pipe between the ocean and the vegetation, and a very thin pipe between vegetation and deep sea. So when you pour a whole bunch of CO2 into the atmosphere, first it will go and fill up the ocean so that they are leveled with each other. And then both of them are going to start filling up the vegetation so that they're all three level with each other. And then all three of them are going to contribute to the deep sea sediments so that they're all level with each other again. So when they're level with each other, the amount of CO2 in each will be proportional to the surface area of each of these cylinders, right? And the way you would model that is you would model that as the product of three exponentials. First exponential is for this process by which the CO2 from the atmosphere goes and equalizes with the ocean. That's this. And then both of them will equalize with the vegetation. That will be this exponential. And then the third will be all three of them equalizing with this. That will be the third exponential. Okay, and each of these would have AI plus BI equals 1. That's the way I would model it. But you know, what do I know? So I have been protesting this environmental gaslighting for years. This is a picture of me with Kimaya in 2002, asking Al Gore to talk about animal agriculture, that 51% is missing, and that he's gaslighting us into just focusing on the burning machine and not look at the killing machine. And in dealing with gaslighting, Ariel Leve has a TED talk where she said, the number one thing you need to do is to remain defiant about the truth. Keep telling the truth about what is going on. Keep telling the truth about what is the real leading cause of climate change. And so, as Kimaya wrote this, she said, stop whatever you're doing and go vegan. Love is all we need. That's the number one thing we need to be doing now. That's the number one message we need to be sending people. And Elie Wiesel said, what hurts the victim most is not the cruelty of the oppressor, but the silence of the bystander. And we can no longer be silent about what's going on. Okay? Thank you very much. I'll stop sharing and then we can field some questions.
Thank you, Salish. Salish, that was wonderful.
Thanks, BJ.
Yeah, that was very good. I have one question about the, and I'm trying to tie, what you said is very interesting, by the way, and I can't quite tie it all, I'm trying to tie it all in together. And one thing I noticed is that the amount of vegetation, which is supposedly sucking up a lot of the CO2, is actually declining. It's been declining for a century by significant margins. So how can people say that the vegetation is taking up the extra CO2? I don't think you can explain it that way, can you? Or what? What's going on here?
That's not my explanation. That is Jim Hansen's explanation. And Jim Hansen was saying that not only are we increasing the CO2 in the atmosphere, we're also increasing all kinds of other fertilizers in the atmosphere.
I wasn't attributing it to you. I was just saying, yeah. How can this even be considered? I mean, to me, because Václav Smil says that that we've lost vegetation. It's declined 17% since 1900, and it's probably, and we're chopping down the forests everywhere.
Yeah, right. I know. It's nature is amazing. I don't know how else to explain it, but the airborne fraction shows what it's showing. Okay, it is going down as a function as we increase the CO2, And that is the only explanation that Hansen has come up with for that. I'm not saying it's correct or not, but I'm saying it puts to rest the idea that it's all coming from past.
So Eilish, I've got several questions, but I'll just do it one at a time.
Okay.
So I'm wondering if by chance you already have this, or maybe it needs to be created, but the life cycle diagrams showing, you know, a chunk of ocean and land, part of a segment of the planet with the trees and such illustrated. I believe, would we call that a life cycle diagram of greenhouse gases?
That's the IPCC carbon cycle diagram.
Yeah, so what I'm wondering if might be helpful, if it doesn't already exist, is that we have the IPCC life cycle diagram, and maybe enhance it with saying, okay, here's your burning machine and here's your killing machine. Have those really clearly illustrated or delineated from each other. And then also, so you got the IPCC life cycle diagram of greenhouse gases, and then we could have the white paper life cycle diagram of greenhouse gases. And just trying to say, okay, here's two professional opinions, people. Sort of goes along with this is another characterization I'd like to share, is that we go to people and we say to them, so let's say you're sick and you go to a doctor, but you're told your doctor is only going, pardon me, mute. So you go to a doctor, are you going to be happy going to a doctor who only is allowed to look at one measure of your health? So that's sort of what I understand you're saying, is that their IPCC is very fixated on carbon dioxide and just this gas perspective. Or do you, if you're sick, do you also, you want to get a second opinion perhaps from a doctor who is going to talk about all kinds of different measures, such as, you know, you get your blood work done, there's a whole page of options my doctor chooses from as to what measures she wants to take of me, you know, and she uses her intuition and some art in a sense to, she's not going to have me get tested for everything, but she's kind of got a sense. So this other doctor, which is you, is going to look at more of these possible influences that are making me feel ill, and also going to present all necessary prescriptions needed for me to continue on in a healthy life, not just being politically influenced to saying, we're only going to talk about this one possible solution for you, and the IPCC politically restricted to saying fossil fuels the issue, everybody look here. No, we're not going to talk about industrial animal agriculture. So I'm just wondering if you'd like to comment on those things. Thank you.
Yeah, the analogy of the doctor is a good one. I think basically it's similar to what is happening in the healthcare arena, where people say, you know, you have a cholesterol problem, so therefore you have to take statins. And then someone else comes along and says, if you just, it's just a foodborne illness, you know, you can just stop eating that kind of food and then your cholesterol will go away. So those are the two perspectives that you're talking about. You know, I think it's very similar.
Okay, I'm in the webinar, so no walk. Yeah. Okay. Okay. Bye. Oops.
Okay, sorry.
Do you think the diagrams that I described, like if we could create, because, you know, the math that you presented is very high level, but if we can create an illustration, you know, the life cycles and present, this alternative white paper life cycle diagram with the burning machine and the killing machine contributions really clearly illustrated. I think that'd be very helpful. And then it's like, okay, people, you got 2 doctor opinions here. Your life depends upon it. You don't have much time left. Unfortunately, we do sometimes just have to say, okay, which doctor do I believe? I'm not going to get a degree in medicine to try to save myself. I'm just going to have to pick the best doctor.
Right. Yeah, we could do a diagram where we show the killing machine operating on the larger 200 gigatons of carbon going up and down, and saying, whatever you're doing there, if you just tweak that, you are now using the 200 gigatons for your benefit. Okay. And if you don't do it right, you're going to use the 200 gigatons to hurt yourself. That's exactly what we're doing now. Yeah.
I saw your circles when you came to Austin, Dr. Rao, about the 3 circles with aerosols being in the middle.
Right.
And when I explain it to people, I use this chart, which you can't. This is the coal, and over here are all the little animals and the trees, so they can see deforestation. And then I draw 3 circles and do arrows about what's happening. I haven't come up with one graphic that shows it, but it's very much like you were saying, the killing machine and then
burning machine.
And they get it. This is creating the CO2 and the methane. This is creating CO2 and the methane. And then I put that aerosols in there, just like you had said.
Right.
Coming up with one graphic, I haven't done.
I'm sure you'll do it, Rebecca.
Hope so.
I have a question. Hi, Sailesh.
Yes, Shankar.
What I understood is there are 2 things kind of doing in a favorable part. One is the nitrogen or N2 or something. I'm sorry if I didn't tell it properly. Mm-hmm. The other one is the aerosols. From a business side or industry side, how we can say these industries, or is it possible to list them as industries, or how to see them? Like, they should continue what they are doing, or should continue as a caveat with something else?
Yeah, the caveat, this is why Jim Hansen called it a Faustian bargain, is that yes, we are cooling when we burn coal, but simultaneously we are increasing the CO2 burden in the atmosphere, which we have to eventually take down. Okay, so we are just postponing our agony for what we have to take down later. This is why I said don't build any more coal-fired power plants, because you're going to keep increasing this Faustian bargain. And of course now Jamin Shively is saying, when we shut down the coal, we need to have replacement mirrors to cool the earth for every coal-fired power plant is shut down. Okay, that's one way to do it. Tell the coal-fired power plant when you shut down, you need to put enough mirrors so that you can reflect that much sunlight back. Yeah, and so this is solar radiation management that comes into play. But as engineers, we know that we cannot willy-nilly do things. Nature is just blindly implementing the laws of physics, chemistry, and biology. She has no, there's no favors, nothing. She's going to give you the consequences for your actions.
Karma.
Karma, and we know that too, right? We know that too. So,
thank you, Sailesh.
Sure.
Sailesh, do you have an upcoming webinar to talk about the political aspects of this? Is there going to be a webinar? Because you started out saying, remember everybody, that what you have are scientists who are hamstrung by the political machine. I'll just make a quick comment myself. So I'm in Canada, and we have a particular political structure and governance system. Many of you are in the United States with a particular governance system. We we'll have to address politics to solve this too. And just make it clear that my participation in climate healers is strictly to be educated, because the action part of it, which you alluded to, it has to be done in my context. And anyone who's in the States needs to act in your context, your governance systems, your jurisdictions and such. So my concern is George H.W. Bush was formerly a CIA director, and your current U.S. Secretary of State is Mr. Pompeo, and he was previously the CIA director. And if you're so inclined, you can find a speech by him just a couple of months ago to a university in Texas. And he says, and I paraphrase, he says, the teachings of the CIA are a lot of learning how to lie, cheat, and steal. Now, your Congress has pretty much abrogated much of its leadership with respect since 9/11. And there's also something else that needs to be brought into it is the, I believe it's the policy for a new American century, words to that effect. So anyway, the reason I only am going to be socially involved with climate healers is because, every action has to be founded on the jurisdiction that you're in, and Americans need to take that, what I just said, into account. I have to similarly look at the flaws of my political system, but we do need to act and create our movements within our context. Anyway,
Correct.
That's enough of me.
Correct. Yeah.
I don't want to, I'm sorry, I have to jump off the call because I'm about to host a meeting with the Vegan Justice League. And what we're doing is exactly what you mentioned, which is getting political and heading a movement that lobbies and creates voting blocks, ousts the people who are not working for progress, and will campaign for people who will work for progress. And it's slow going, but I see it as exactly what you said, Miles. We have to get political, and we have to get the people out who are trained in lying, cheating, and stealing, and get people in who understand the science and are willing to listen to scientists like Dr. Rao. And I just want to say thank you so much for presenting this, and I look forward to the next webinar. You're really, I was kind of like onto a lot of these, looking into methane, looking into animal agriculture, and you've done the work, so you just make it so much easier for me to go, oh, okay, that's how it is. I don't have to do so much homework. So thank you so much. Your framing of the killing machine and the burning machine is just incredibly useful. So thank you.
Thank you.
And I'll see you on the next call.
Thank you.
So I'm just going to mute and listen to your answer to Miles's question, because I just kind of jumped in and said my thing. So, and then I'll jump off the call.
Yeah, I wasn't planning on doing a webinar on just the politics of it, because I'm a scientist, I'm an engineer, and I'm looking at things from an engineering perspective. So, but I'm just giving you observations that based on what I've seen in the past and what is happening now, I see the parallels, and I see this is really what's going on. And so therefore, we need to take everything, with that perspective, and do our own science, do our own understanding of the science. And so this is what I've been trying to do ever since I did that protest at Al Gore's training. I've been focused on this. Yeah.
Another Canadian speaking here. I don't think that, well, we do have different political systems. I don't think that Canada is any better than the United States. In fact, I think we're much deeper mired in the language of resources. The environment is resources. Canada has great resources to share with the world. That means burning it. That means cutting it down and sharing it with everybody in what we call trade. George Monbiot has a great post. I think it's pretty recent. I just found it today, where he's talking about we're not going to be able to do anything as long as we've got a system that thinks that we have infinite growth. Ask any politician, do we need to grow the economy? If the answer is yes, you can stop talking to them. There's no political solution. They're not designed, they weren't elected to say yes to you. They were elected to grow the economy, and everybody, until we agree that is not the solution, political solutions aren't going to be the things that are going to give us what we need. We need to, a part of what we're doing is to build something that's new and better and sane, rather than doing the same thing over and over again. I think every environmental activist, especially climate change activists, should be extremely frustrated with the lack of progress they're getting with governments. And instead of doing the same thing, do something different. Start thinking about, different methods. I like the Extinction Rebellion, their agenda to get the government's attention and take some of their power away, so that those industrial obligations that governments have go into the hands of somebody that we choose to make those rational decisions. Will the government concede those powers? I think it's going to be a long time before we see them make those choices, exactly because they have the elected responsibility of growing the economy. It's kind of like saying that, you hire a postman to deliver the mail, and you're suddenly asking him to deliver a hot pizza. And they kind of look at you a little bit strange and go, that's not what I'm supposed to do. That's not what I've been hired to do. And you're asking me to do something that's different. And their governments compete with each other. They compete from country to country. So we have to look at this as a global solution, and a collection of countries that have a you first attitude isn't going to be the source of those changes.
Preach it.
This is Joyce. Am I on?
Yes, you are.
Oh, okay. So I have a lot of questions. I just got on about 5 minutes ago, so I don't know what you already talked about. But one thing I would like clarified is with burning coal, are there more dimming particulates coming out of that? What's the ratio of dimming particulates to the heating from burning coal?
Yeah, we went through all those numbers. So I would suggest you look at the video after. I'm going to put it up by the end of this day. Yeah.
Okay, cool. And the other thing is, I have been out there with. First of all, I made a flyer that I take everywhere I go, and especially the young kids. I hand it to them because they are really. I think everyone that I've encountered is open. And the Sunrise kids that came to the town hall that Bernie had in San Francisco, they came en masse, and I talked to them all, and a lot of them were already vegan, which was very exciting. And to me, the great thing about what I've seen from what you're doing and what I'm getting from that, and from the World Watch paper, and from Professor Poor's paper, is that we don't need to pass legislation. We do not need to take all this time pushing against the fossil fuel industry. We need to, and this is what my mission and goal and what I'm doing, is to spread the word as best as possible about the impact from food choice. And, I have been working on how to message this. I've been giving PowerPoints. And to what the Canadian man said previously, I'm part of the DSA, Democratic Socialists of America, and I've given PowerPoints there. And so far they are the most receptive, because they understand the connection between capitalism and growth and our whole system. And I agree that it's in the political realm. In the U.S., as you can tell, the what is the purpose of government? They're always talking about promoting American interest, which basically means business, which means growth. So one of the things I'm going to be doing, so I'm going to be taking the CHIP training, which I can't remember exactly what it stands for, but basically it's a pre-set up demonstration over some, I don't know, months or weeks or months, with videos where you show how a plant-based diet is good for health. But however people come to it, it doesn't matter because it has the same effect. So I am going to go, I've talked a little bit to the Cupertino City Council, so I'm in the middle of Silicon Valley, and I'm hoping to actually make some progress there. And I think through the health aspect, and I want to hear feedback from you and everybody on this. I think that it seems, at least with the older people, that resonates more with them than the, unfortunately, the climate aspect, because it's people can't get their mind around it yet. So
yeah, no, it's good. I mean, I think going to the local government is the best way. If you can do anything, it'll be in the local area.
Mm-hmm. Mm-hmm.
Yeah. Also, the question from Rebecca about the fires in Australia must be contributing greatly to CO2. The estimate I've seen is that it's burnt about 15 million acres. I'm not sure if that's the latest one now, but 15 million acres would, I think annually we burn about 30 million acres, and then we restore maybe 10 million acres. So the IPCC is counting 20 million acres as deforestation, which is where they come up with the 1.1 gigaton number. So we have added about 15 million acres to that.
So, hi, Doctor. This is Harsha from Mumbai. And since we are talking about politics and environment and all, I just, as I remember the last time we spoke about how are we approaching organizations like Fridays for Future and all. So I just wanted to give an update on this, and I feel like you and everyone in this conference would be benefit from knowing it. So a few days ago, I have contacted one of the core organizers of Fridays for Future from Sweden, Greta's home country, and I tried talking to her about vegan and climate, how it is animal agriculture is related to climate crisis and everything. So from the long discussions I had, I came to an understanding that their current goal and only goal is to recruit as many volunteers as possible to protest in front of the governments and industries. That's their one and only goal. And the second thing I realized is they have absolutely no interest talking about animal agriculture. They don't want to talk about it. They don't even care about it. And when I asked very in an extreme polite way possible, and is the organizer or the court committee team, are they vegan or not? And the response I got was, it's none of your business. So it was a little upsetting. So I thought like I should let you know so that you can prioritize your work with them.
Right. Now, don't go to the top. Always go to the local people. And the local people, you will find that they are more amenable because the top has already been bought and paid for. So usually that's what happens in any of these major organizations. Any organization that gets to be really big, gets more and more corrupted, unfortunately.
Yeah. So when I asked more questions, and I got the typical non-vegan environmentalist responses like, vegan food is is quite expensive. We don't want to force anyone. We don't want to scare anyone. Yeah, these are the responses I received. Yeah.
Right.
Thank you.
Yeah. Sure. Okay. Thank you very much. I'm going to stop the recording. And we